Hi everybody, and welcome to example 5 on page 50 of the workbook here. This is going to be another example of finding matrices of linear transformations. Okay, and this video we're just going to look at part A here. All right, so first notice the instructions. They'd like us to find the matrix of the transformation T taking us from beta to gamma coordinates. Okay, and then the actual transformation that we're going to look at is a transformation from R3 to R2 that looks like this. Here's our definition. And then they give us the bases beta and gamma. Okay, so we're going to follow the same process that we did in the last example. So we'll start by focusing on this basis, beta, which is the basis that we're thinking of going with our inputs. Okay, so we'll take the vectors in beta one at a time. Okay, here's the first one. So we'll substitute that in. T of 1, 1, 1, and then we'll do it for the other three, or for the other two as well. So next beta vector looks like T of 1, 1, 0, and then finally T of 1, 0, 0. Okay, so we can calculate those by looking at our definition for T. So if we start with T of 1, 1, 1, we're just substituting 1 for all three of those variables. So let's see, first coordinate will look like 1 plus 2 times 1. That's going to give us a 3. And then the second coordinate is going to be negative 1 plus 3 is 2. We plug in all of our variables. So we get 3, 2 out. All right. And same deal for the other two. So now we're ready for T of 1, 1, 0. So this time A1 and A2 are 1 and A3 is 0. Okay, we're going to substitute into our same formula, and if you do that, let's see, 1, 1, 0. That's going to give us a 1 plus 2 is a 3 in the first coordinate. In the second coordinate, we're going to get negative 1 plus 3 times 0. That's just going to be negative 1, it looks like. All right, and then finally, T of 1, 0, 0. This time, just the A1 is equal to 1. All the other variables are 0, so we're just going to get a 1, 0 out of that. Okay, now we're ready to look at the basis that goes with our outputs, gamma. So these three outputs that we got, we'd like to write those as linear combinations of our output basis. Okay, and our gamma basis looks like this. All right, so we'd like to take 3, 2 and write it as a linear combination of those two vectors. Okay, and same for the other two. All right, and the nice thing is our output basis consists of just the standard ordered basis for R2, so these blanks are not too difficult to fill in. To build a 3, 2, we need a 3, 2. Okay, 3, negative 1, same deal, and then finally 1, 0, same deal. Okay, so we have all the information that we need to write down our matrix. Okay, let's review that process and how it works. So the matrix for T, taking beta to gamma coordinates, would look like first column is going to be given by these two numbers, 3, 2. Second column is going to be given by those two numbers, 3, negative 1. Okay, and then finally, third column is going to be those two numbers, 1 and 0. Okay, and there's our answer.